For the homework problem video today, I would like you all to try this on your own. See if you can find what you think all the critical points are going to be, and then I will talk through it myself, and we can see if we get the same things. This is problem number 1. When I look at this, it says, all right, we'll start by finding all the critical points. So we have a critical point right here, right here, right here. Derivative, critical point is derivative equals 0 or does not exist. All right, did I miss any? I think that's it. Okay. So how do we identify these? Local max, local min, or neither? Let's color code them. Say local max is going to be red. And then let's say local min is going to be blue. Means I need to go over some of these. So here's a local min, and local min. Great. And then we should write these as actual points, right? But we can't because we don't know the y values. It doesn't actually tell us the y values. So I'll accept a graphical answer here, or you could say, local max when x equals 3 and I don't know, 4.8. Hard to tell on some of these. 9.2, just guessing. And similarly with local minimum. All right, negative, maybe it's like 4.2 and 7 and 10.2, I don't know. And then we can find the global max and min as well. That will either be at a critical point or at an endpoint. So the biggest the function ever gets is up here. The smallest the function ever gets is right there. So we can say global or absolute is, I don't know, it doesn't tell us the y value, but that's going to be when x is 13. The global min is, again, we also don't know. But that's going to be when x is 7. That's all they're looking for here. Good practice just visually identifying what these terms mean. The next one's a bit of a weird problem. It's a good conceptual problem. Give you some practice with that. Let's say s is the slope function between the origin. So this blue line always starts at the origin and it goes to some point on the graph. And s will be the slope depending on what point that is. So s of 2 will be the slope of this line. The slope of this line is s of 2. S of 3 will be the slope of this line. S of 5 will be the slope of this line. Okay? So at what value of x is s of x minimum? Where is that slope going to be minimum? Not the slope of the function, but the slope of this blue line. And it looks like maybe it'll be here, or maybe it's over here a little bit. Yeah, it looks like it's maybe about here. It looks like this is where the slope is going to be the smallest, the flattest the function will ever be. All right. You can't find this out exactly. I believe this is a much more complicated problem. But it gives you some derivative practice here for the concept of the derivative. So let's say that's about when x is 8. Where is it the maximum? Where is the slope the biggest? I think it might be here. Is there any line with a steeper slope that you can think of? I don't think so. I think this is the steepest slope that we're ever going to get between the origin and any other thing. So that's going to be my answer here. X equals 2. All right. There's a couple of ways that you can do this algebraically if you know the function, but this is all it wants you to do is just get practice constructing and playing with this idea. All right. Anyway, that's it. Hope these helped. And I think most of the homework problems are pretty similar to the problems in the lecture videos, so I didn't choose to do any more, but you can always ask me if you have questions or if you get stumped on any of them. Anyway, have a good one. Bye-bye.